Okay, good afternoon, good morning, good evening. I'm going to do a couple of quick solutions of Phab 5 questions for you. One is going to be just one of the regular Phab 5 now that you've written a quiz and you can appreciate better the problem solving methods. The second one, I'm going to take the Phab 5 tough questions, numbers 65, 66, 67, and 68, and have a go at those. This might end up being 2 videos. So grab your notes, grab your questions, and let's have a look at one of these. Phab 5. Let's try the CN tower question because it involves the kinematics equation that you're going to use most often. So the CN tower question, I'm going to take the 7-step method. I believe it's somewhere around number 50. If you take a quick look, pause your video now and find the first CN tower question. There are 2 where you drop a penny from the top of the CN tower. I'm going to go with the first one where the initial speed is 0. You just let the penny go. So the question asks how long it will take the penny to reach the ground. Step 1 in the 7-step method, write the target. So I've written the target as seconds, and then underneath I would write myself a little reminder to change my final answer into the proper amount of significant digits. If I already know what they'll be, I can write that down. But sometimes it can be a little deceptive. Sometimes you aren't going to use a number that you would think would decide your sig digs. So let's just solve the problem first, and then we'll deal with it. So step number 2 is to draw a diagram, get the concept, figure out what's happening. This one's pretty straightforward. We have the CN tower. We have a penny dropping down from the CN tower. It's got a height of 553 meters, so our distance traveled would be 553. Notice that I'm doing steps 2 and 3. I'm writing in given information. V1 is 0, and we're given that acceleration due to gravity is 9.8 meters per second squared towards the ground. So we're going to treat this whole thing as though down is positive. The reason for that is everything's going that way, so there's no sense putting negative numbers in. So we're required to find t, and we're given d, a, and v1. So we need an equation. Step 4 is to find an equation that has those 4 variables in it. And the equation would be the third one, the first one that we derived for the first 2, and that is d equals v1t plus 1/2 a t squared. And if we're solving for t, this can involve the quadratic formula, and in fact, in the next question it does. But in this question, we're lucky because v1 is 0, which gets rid of that statement. So step 5, algebraic manipulation. D equals 1/2 a t squared, and we have to rearrange for t. So we multiply both sides by 2 because we're dividing by 2 right here. And we divide both sides by a. So we're going to end up with 2d over a equals t squared. And finally, our fully manipulated equation where we solve for t, it's going to be t equals the square root of 2d over a. Plug the numbers in, and we get the square root of 2 times 553 divided by 9.8. Do the calculation quickly, and we get an answer of 10.6. But because we were given significant digits in the question, the given information, we had 3 sig digs here and 2 sig digs here. Our final answer has to have 2 significant digits, so we would round 10.6 to 11 seconds. So there's the easy question. Now I'm going to take another question here that is one of the more complicated questions. So question 67 in the textbook is a question about Superwoman. Superwoman is hanging out doing her thing, and a parachutist falls past her. So let's if a parachutist falls past her, then she accelerates down to try and catch the parachutist before they hit the ground. Let's start, we were asked for her acceleration. Let's start with that. Step 1, acceleration equals something, meters per second squared. Remind ourselves about the sig dig significant digits. Step 2, draw the picture. So in this case, we have Superwoman. Let's see how well I can draw Superwoman. Put a red cape on her, just for fun. We have a parachutist that falls past her. At a terminal velocity of 140 kilometers per hour. Now, step 3, we'll put the numbers in, but I'm going to break this up a little bit. I'm going to put it up here. So step 3 is to take the numbers that we're given. Now, Superwoman starts with a velocity of 0. Let's put an S up here to identify that as Superwoman's information. She starts with a velocity of 0. She goes a total distance of 1,000 meters, because that's where she starts from. We don't know her V2. We don't know her time. And we don't know her acceleration. In fact, that's what we're trying to solve for. So let's just take that one out. The parachutist, on the other hand, Superwoman is going to be accelerating. She's got a constant acceleration situation. The parachutist is going at a constant speed. So the parachutist is just going to need distance, speed, and time. Now, we don't know the time. We know the speed, 140 kilometers per hour, which we can convert to meters per second. And we'll take a look at that in a couple minutes. And the distance, we can actually figure out, because it says that the parachutist falls from the 1,000 meter mark for 1.9 seconds before Superwoman starts. So we can determine, let's figure out how far she falls first, and that's going to be 1.9 seconds times 140 kilometers per hour. Now I'm just going to do the conversion on the side here. A little trick we have for converting kilometers per hour to meters per second. If you remember what we do, kilometers per hour times 1,000 meters per kilometer times 1 hour per 3,600 seconds. Well, this is the same thing as multiplying by 1,000 and dividing by 3,600, which is the same thing as dividing by 3.6. So if we take 140 and divide by 3.6, that will give us our speed in meters per second. Shrink that and get it a little bit out of the way. So we can change our value to 1.9 seconds times 140 over 3.6 meters per second, which will give us the proper units. So punch that into your calculator, pause the video as you want. I get 73.8 repeating meters, which means this distance, the actual distance the parachutist travels, we'll call it sub-parachute, is going to be 1,000 minus 73.8 repeating, which is going to be 926.1 repeat meters. So now we have a distance for that, the parachutist. To divide things up here a little bit and give us room to do the rest of the calculation. So now we know that Supergirl, Superwoman, has an initial speed, a distance, and we're trying to find acceleration, so we need one of these two. More likely, we're going to be able to use this, and I'll tell you why. Because both of them start at the same time, which means they both fall for the same amount of time. The parachutist falls 926 meters in the time that Supergirl travels 1,000 meters. So when we want to solve this, we can put the two times equal to each other. So let's play with some equations here. We're on step 4 now. If we have acceleration, the initial speed, distance, and time, then again, we're using the third equation. Distance equals v1t plus 1/2 a t squared. This is Supergirl's motion. And we can simplify it because, again, she starts at 0 speed. So it's distance equals 1/2 a t squared, or a equals 2d over t squared. We also know that t is equal in both. The parachutist is following the equation d equals vt. So the time is going to be the distance the parachutist falls divided by the parachutist's speed. And we can take this and say it's the same thing as the t here, which means for acceleration it's going to be 2d over parachutist distance divided by parachutist speed squared. And we have all of these numbers. Plug them in now, pause the video, try and get the answer. So here are the numbers. 2 times 1,000 divided by the distance of the parachute divided by the speed parachute squared. And we get a final answer of 3.5 meters per second squared. Check that in the textbook. Bug me if you find it wrong. So good luck. Try the other ones. See what you can do. Remember, these ones involve substitution. They involve two different sets of motion, but there's something common between them. And try to find that common ground. In this case, it was the time. Okay, so good luck.